So you don't have to work for Simulink. So I welcome you all to the class of DSP. In continuation with the previous lecture, we have started with LSI systems, linear shift invariant system. And in continuation with that, today we will discuss about LSI systems only, its properties, and then we will simplify some numericals. So if you are having any doubt, you can ask. And right now in your DSP lab, you have to work with the programming. So any more students are joining, because till now 6 students, it's 3 8 right now. Others are joining. And if you are having any query regarding your lab or theory, you can discuss. See, right now in your lab, you have to write the codes. You have to write the programming. The program which you have written in C language, in Java, in C++. We didn't use Simulink. You are writing the code. So here also we have to write code. So for that, writing coding, we should know the language. And it's a very good software. So many toolboxes are there. Whatever is your field of interest, you can start working with that. And in college, we have purchased version of MATLAB. But for students, right now you are sitting at home, you can get free cracked versions and you can start working on that. But don't sit idle. Just try. Go through MATLAB. There are so many PDFs available. From MathWork, you can learn many things. So students, others are joining or not? As I'm waiting to start. No others are joining. Only 6 participants today. You said in previous lecture there were many students. So we should start. So yesterday we have discussed regarding basics of LTI system, and we have discussed convolution, property of LSI systems. Then we have discussed stability, causality, properties of LSI systems, commutative, distributive, and associative. In parallel with that, we can have parallel and series or cascade interconnection of systems also. These 3 properties we have studied. If we will study frequency response of interconnection of a system, so we can interconnect these systems parallelly or we can cascade those systems. It means I am having 3 systems, H1 of Z, H2 of Z, H3 of Z. I can parallelly connect all those systems or I can cascade depending on our requirements. Okay. Next, LSI system with and without memory. With and without memory means your output is depending on the present input or on the past outputs and present inputs. So if a system is a memoryless, if its output at any time depends only on the value of its input at the same time. Got the point? Memoryless means my system, this is my system, this is my present input, this is my present output. This is my system. I am considering only a single system. Present input, present output. Present output only depends on present input. So that system is a memoryless system because it don't require anything to get stored in that device. So it is memoryless. This is true for a discrete system if h of n is equal to 0. If h of n is equal to 0 for n not equal to 0. The impulse response is the form. This is the impulse response. H of n is equal to k del n, where k is equal to h of 0 is a constant and the convolution sum reduces to the relation y of n is equal to kx of n. Y of n is the multiplication of input and system response. X of n into h of n is my y of n. And what is h of n? H of n is k del n. Del n value n is equal to 0. It is 1. So h of n is k. So y of n is equal to k x of n. Otherwise, the LSI system has memory. If this is the condition, it is a memoryless system. Otherwise, it is with memory. Next is invertibility of LSI system. What do you mean by invertibility? It's a very important property of a system. We have seen that a system S is invertible if and only if there exists an inverse system S inverse such that S inverse S is an identity system. You have studied identity property. X multiplied by 1 upon X will be 1. That is my identity property. Input multiplied by reverse input system is an identity system. So that is my invertible system. So here what I am showing, input given to a system H, whose reverse system is again multiplied, that is H1. So output will be equals to the input y is equal to x. This is my invertible system or identity system. This is the example shown. Overall impulse response in the figure above is h into h1. H1 must satisfy for it to be the impulse response of the inverse system. Namely, h into h1 is equal to del. So that you can get output equals to input. What are the applications? Applications are major applications in the telephone system, communication system, channel equalization, radio links. In filtering, it is required identity system ki output should be equal to input. There should be no change in the amplitude of output and input. Consider a system with pure, okay, this is the example that we will discuss later on. This is one of the example of summer. Consider an LSI system with impulse response h of n is equal to u of n. The response of the system to an arbitrary input is y of n. This equation we know, convolution equation x of k into u of n minus k. U of n minus k kya hai? That is the system response h of n. X of n into h of n. Convolution of x of n into h of n. The convolution formula is this. Okay. Considering that u of n minus k, what is u of n minus k? It is the unit step response which starts at n is equal to k. K could be anything, 1, 2, 3, 4, anything. Okay. So here I get this limit. Here I have put minus infinity to infinity. Here I am putting minus infinity to n because s k n is equal to k. This is a system that calculates the running sum of all the values. This we know, summation of input. So it is summer, or we can say it is an accumulator. This system is invertible and its inverse is given as, how we can find out its inverse system? Y of n is equal to x of n minus x of n minus 1. It is a first difference operation. Difference operation, it is the impulse response of this inverse system is del n minus 1. So now what will happen? I know h of n, I will multiply h of n by h1 of n. And then I should get the input, exact input which was given to the system. So the system should be invertible. Next is causality. for LTI systems. We all know what is the causality property, how the system is causal. Do you know causal systems? A system is causal if its output depends only on the past and present values of the input signal. That means it should satisfy the condition h of n is equal to 0 for n less than 0. Causal systems are the systems whose output depends only on the past and present values of the input signal. That means it doesn't depend on the past values of outputs generated. If it depends on the past values of output generated, it is a non-causal system. So for a discrete LTI system, this requirement is y of n should not depend on x of k for k greater than n. Based on the convolution sum, impulse response of a causal discrete LSI system should satisfy the condition h of n is equal to 0 for n less than 0. A causal system is causal if its impulse response is 0 for negative time. This makes sense as the system should not have a response before impulse is applied. Got the point? It's very simple, very easy, which we have discussed earlier. These properties are applied on LSI system, linear shift invariant system. Stability is very important. It gives you an idea of bounded input produces bounded output, that is BIBO stability. Bounded input produces bounded output. This is the condition for that. That means it is having some finite values. X of n should be less than equal to p, some finite value. So the output is also again bounded by that magnitude, which is shown here. Y of n magnitude is shown, which is should be less than equal to b times h of k. So y of n is bounded in magnitude and hence it is stable. And the condition to be stabilized depends on now h of k. H of k should be less than infinite. Is it clear? Bounded input, bounded output, BIBO stability criteria. So LSI system should have this property also. So examples are given over here. Now we'll discuss this very important parameter. See, the accumulator h of n is equal to u of n is unstable because after adding number of values, the result becomes unstable. Accumulator is a device. What it will do? It will add all the values. It will add all the values and store the previous value. Again, it will add that previous value with the present value. Okay, now we will discuss the unit step response of an LTI system, which is very important. The step response of an LSI system is simply the response of the system to a unit step. Getting the point? Input is your unit step. The step response of an LTI system for a discrete time system with impulse response h of n, the step response is this. S of n is equal to u of n into h of n. U of n is my unit step multiplied by the system. However, based on the commutative property of convolution, you can have S of n is equal to h of n into u of n. This property we know, and therefore S of n can be viewed as a response to input h of n of a discrete time LTI system. We know that u of n is a unit impulse response of the accumulator. Therefore, S of n is equal to this, minus infinity to n. From this equation, using the relationship this, we can find the running sum of its impulse response. So this is not that important. You should remember all these properties. Now, we will discuss one more thing before going to the very important topic of LSI system, that is LCCDE equation. We will first see some introduction part. See, this is the DSP system. Input given to you, and now after discussing all the basics of linear shift invariant system, what you came to know, this DSP system should possess all the properties which we are discussing from two classes. The properties which fulfill your system to be linear shift invariant. So this is my DSP system. So what will be the output? Y of n is equal to function of x of n, where function is an operator, f is an operator, and we have to decide what should be this operator. So all the basics we have discussed till now. So now a very important thing, impulse response of a system. Here in this diagram you can see we are giving an input impulse. Impulse is located right now at n is equal to 0 and amplitude is 1. This is given to the LSI system or LTI system. What will be my output? Now this is my input given to the system. System h of n response will be multiplied, but what we will get, whatever is my h of n, we will get at the output. Because it is just for n is equal to 0, it is 1, otherwise it is 0. So located when the initial condition of the systems are 0. So output response totally depends on the system response when input is your delta function, impulse response, units sample. This is known as the impulse response of the system. When we are giving an impulse, output will only depend on the system's response. So students, any doubt, anything you want to ask? Now what we are doing, we are shifting the input pulse. If I have shifted the input pulse, output should also be multiplied by that factor. So it is the shifted impulse response, time shifted impulse response of LTI systems. Is it clear? Anything you want to ask? Okay. So this is again shown to you. Shifted impulse pulse n minus k is equal to 1 for n is equal to k. Otherwise it is 0. So this is my del of n. This is shifted del of n. What do you mean by del of n minus 2? The impulse exists at n is equal to 2. So here we have shown the shifted impulse response. Clear? Now the response of the LTI system to the unit impulse sequence del of n is represented by h of n. Is it clear? This we have discussed in the first figure. The response of the LTI system to the unit impulse sequence del of n is represented by h of n. So h of n is equal to operator del of n. Y of n is given by this equation. This we all should know. And this is given by convolution of input and system response. So I will get y of n is equal to x of n convolution h of n. We are going reverse. Okay, we are going reverse. We all know y of n is equal to x of n convolution h of n. So we are proving it. That function operator is x of n, where we all know h of n is del of n minus k. We are taking it as impulse response. Multiplying these, we will get x of n convolution h of n. Or equivalently, you can write h of n convolution x of n. And convolution we have discussed in previous class. Now unit step response. पहले हमने impulse response देखा, अब हम देख रहे हैं unit step response. The unit step sequence u of n. We all know u of n. This is the signal. See, you can see x-axis is the values of n. 0, 1, 2, 3, 4. Infinite number of sequence it could be. Students, are you listening to the presentation? Is it audible? The slides are clear to you? Okay. So u of n, this is shifted u of n minus 2. The shifted unit step sequence, okay? So for shifted, the convolution formula will be h of k u of n minus k or x of k u of n minus k. X of n is equal to u of n. So x of n is equal to u of n. This is my system response and this is my input sequence. So convolution formula मैंने लिख दिया है. Relation between the unit step and unit sample and unit step. Del n और u of n का relation बताया है इसमें. How you can get unit sample response, unit step response from impulse response. Summation of impulse will give you unit step. This you should do. Properties of DSP system हमने देख ली है. It is linearity. We all know linearity should follow with the principle of superposition. Superposition means property of, क्या डिस्कस किया था हमने कल linearity में बताना. Please write in the chat box how we will prove that a system is linear. Yes, Amisha, Sakshi, Aditi. How we can prove that? How we will apply superposition theorem? No one is answering. भूल गए? Okay, I'm waiting for your response. See how we can do, because it's showing in the screen. So at least you can tell me how we can prove that a system is linear. It means there are two things we have to prove to be a linear system. Two conditions are to be satisfied. What are that two conditions? Which we have discussed. Yes. Yes. So we have to prove homogeneity and additivity to prove linearity. Is it clear to all? So see, you can see this example. You can write the examples in your copy if you want. So first example, we have to prove whether the systems are linear or not. So this is my example. F of x of n is equal to a n x of n plus b. Now I have to prove whether it is linear or not. So in your copy, you can simplify. What I will do, this is my x of n. First, I will write x1 of n and x2 of n. This x of n, I will put it as x1n plus x2 of n. So what will happen? X of n यहाँ पे भी तुम्हारा split हो जाएगा x1n plus x2 of n. Is it clear? Function x1n plus x2n should be equal to function x1n individually plus function x2 of n. So whether the system is linear or not, can you tell me? Now f of x1 of n individually I have added with f of x2 of n should be equal to this. So here I am getting this and After adding individually, what I am getting? I am getting this equation. So are these equations same? These two equations are same. Yes, students, these equations are same or not? No. Very good. These equations are not same. So it is a non-linear system. This system is non-linear. Now please simplify the second example and tell me the answer. Do it fast. Till that time, I will take your attendance. Aditi, Amisha, Avantika. Then Pranjali, you were absent yesterday. Pratibha, Sakshi, today Shubham is absent. Absent क्यों हो गया? कल क्वेश्चन पूछ लिया इसलिए. All were aware ना I am taking class at 3 or there was any confusion. Okay, simplified the second question. E to the power x of n, very easy. And tomorrow's class is postponed to Friday. Yes, students, are you simplifying? Okay. So is it linear or non-linear system? Linear. सबको समझ में आया या कुछ ही बच्चों को समझ में आया है? You have any doubt? System is linear. Okay, see the answer now. F of x of n is e to the power x of n, which is given to you. F of x1n plus x2 of n is equal to e to the power x1n plus x2 of n. एक ने linear लिखा, सबने linear बोल दिया. Very good. See on the slides. e to the power x1n plus को तुम split कर सकते हो in multiplication. It's an exponential function. Okay. Now by writing individually f of x1n plus f of x2n is equal to e to the power x1n plus e to the power x2 of n. Can you combine this thing? Is it same, these two equations? No, they are not same. So how you all are writing it as a linear system? It is an example of a non-linear system. What mistake you did? Are you getting the point or not? Yes or no? Any doubt, any confusion? So I should discuss it if you are not getting. Is it clear to all? Now try for this, check whether the following systems are linear or not. Do it fast, do it fast. We have to do for many numericals, and this is very basic linear systems. You all should know. Is it linear, non-linear? Any answer? First is linear, second is non-linear. Acha, any other answers? Yes, students, waiting. Okay. Second is non-linear. Okay. So how many are right? You can see the steps. Y of n, y1n plus y2n. This is individual. Adding, you will get this, which is same as your y of n. So it is a linear system. First is, second, y of n is x1n plus x2 of n square. Then individually, whole square is there. Then individually you will add these terms. You will get a different equation. The system is non-linear. Very good. So you all got these things. अब ये questions homework में लिख लो. 5.4. Test the following system for linearity. Take it as a homework. 5 sin x of t, 7x of t plus 5. These two equations. लिख लिया सबने? We wrote this numerical. Okay. So we'll move ahead. Now write down this question for your homework. 5.9. Check whether the following systems are linear and time invariant. Write down in your copy this question. Written both A and B. 5.9. Finished. Okay. Simplify this thing. Next, for causality, write down this numerical. Prove whether the systems are causal or not. Equation लिख लो. Causality property is very easy actually. By looking towards the equation, you can find. So don't write it, just tell me. A is a causal or non-causal? We all know the condition of causality is this. So it is a non-causal system because the output exists for your n is equal to -2. H of n is equal to 0 for n less than 0. This is the causality condition. So first is your non-causal system. Second is your causal system. Is it clear? Second is your causal system, and third is again your non-causal system. Clear? So we should go ahead. Any doubt you want to ask? Stability property, we all know bounded input, bounded output. Stable region, the permissible region for the location of poles of our stable and unstable systems are illustrated in figure 5.6. Within the circle, this is my stable region. Next, we will discuss simplified any doubt you want to ask? 5.5. See this stability, BI, stability, this condition we have discussed. How the output will be bounded, how the system response will be bounded, that you should know. Now, a very important aspect, magnitude and phase spectrum of linear shift invariant systems. This is very important to simplify all the numericals based on LSI systems. So, for any system, we should know what will be its magnitude and phase. So, here what we will do to find what are the steps to find the magnitude and phase. So, see students, write down this steps in your copy, and in next class I will continue with the discussion. So magnitude and phase spectrum, and we will in continuation with this discuss IIR system and FIR system because it is the extension of LTI systems only. How the equations are written in LTI systems? It is written by linear constant coefficient difference equation. LCCDE equations are written, and on that basis we are classifying the system as IIR systems and FIR systems. So in next class we will continue with this topic, and if you are having any doubt you can ask and write down this important topic of LTI system in your copy, magnitude and phase spectrum. So the screen is shared with you. You can write the equation. Any doubt, any query you want to ask? No doubts. Okay. Goodbye, students. The screen is shared with you. You can write. Is it visible properly to you? This HR is the real component, HI is the imaginary component. So is it finished? No need to write the theory, but this bold terms you should write in your copy. That is very important. Sorry. Final equation h e of j omega square is equal to hz inverse at z is equal to e to the power j omega. So to simplify all the questions of LTI system, we should know Z transforms very well because it becomes easy. You can also simplify it in terms of Fourier transforms. So is it finished? Okay, students, goodbye. Take care of yourself. In next class, we will continue.